Good people, welcome to GJ Tech Tutoring, but also welcome to the series of ODE. Right, now we are going to be doing applications of first order differential equation, right? So it's the third video on our series. The first one was linear ODE, second one was binary. Now we are doing application of first order differential equation. Now we are going to be focusing more on heating and cooling. We're going to be focusing on heating and cooling. Now, under heating and cooling, we use Newton's law of heating or cooling models, right? That rise or drop, right? So now they are actually portrayed by the equation dt over dt, right? The capital letter D over the capital letter T over the small letter t, right? Right, so the capital letter T over d small letter t is equals to plus or minus k, open brackets, t minus tm. Now, this is our formula of heating and cooling. Right, now what we need to know is that this is our rise or drop constant proportionality. So this is our rising rate or dropping rate. Right, so we always need to understand how do we go about these signs, because if you don't take them correctly, then they're gonna ruin your solution, right? So what you have to know is that when it is rising, it's positive. When it is dropping, it's negative, right? Now, when we're talking about heating and cooling, if K is greater than 0, if K is greater than 0, that means it's heating. If K is less than 0, that means it's cooling, right? This is just a basic knowledge. This is just a basic knowledge, right? So when the temperature is increasing, then when the temperature is increasing, then it's heating. When the temperature is increasing, it's heating. Then when the temperature is cooling, then it's decreasing, right? So when the temperature is going down, then it's cooling, which is negative. When the temperature is going up, which is heating, then it's positive, right? So such things, right? So that's how you can be able to choose, right? Now, let's say we're just choosing positive. Then first thing first, we need to know that we have to use direct integration, right? So we're going to have dt over is equals to kt minus tm, right? Then from there, divide both sides by t minus tm, then dt over t minus tm is equals to k dt, right? Now, in this, we have to just apply direct integration, which is integrate both sides. Then we're going to have ln of is equals to kt, right? kt then plus c. This is our general solution. This is our general solution. So this is basically how it is. So in most cases in your test or in your exams, they will want a general solution. They will want the formula that you guys can use, and on top of that, they will ask you to write the general solution, right? So now we need to do a little bit of an example. Right? So this is our example, right? Now, it's saying a chicken has been kept in a refrigerator at the temperature of 40 degrees, right? And then placed in an oven that was preheated to a temperature of, so that means it was preheated. So it being preheated, that means it makes the ambient temperature or the room temperature of 325, right? The room temperature of 325, because this was now found by the chicken, right? So in the oven, there was a temperature of 325. In the oven, there was a temperature of 325. That was the room temperature. Right, now after 20 minutes in the oven, the temperature of the chicken is, so after being placed in the oven, the temperature of the chicken increased to 60 degrees, right? So now the temperature was initially 4 degrees of the chicken. Now it's 60, right? Then this happened after 20 minutes. So you can just say time 20 minutes, then it was 16 degrees. right? So now the question is saying, how long must the chicken remain in the oven to reach the temperature of 185, right? Remember, where did the temperature start? It started on 40 degree. Now it's going to 180 degree. So that means this is to increase. So if this is increase, then instead of plus or minus, we're going to just use plus because it's increasing, right? Now let us write the formula of Newton's law of heating and cooling. We always have to start writing it. Now we wrote it. Now we have to take it to the one that we need to use. This is the one that we need to use. We're not going to use minus because it's increasing to this 185 to from 40, right? So when they're saying how long, that means they're asking time, right? Now, we need to write a general solution. First thing first, we have to write a general solution. Probably it can be 2.1. Write a general solution. So we have to derive a general solution. Then direct integration. Right. Then this is our general solution. Right. Now we have to make at least T subject of the formula. Right. Then let us let E to the power C to be an initial temperature, right? An initial temperature. This is our initial temperature. So this is our formula. This is our formula. So this one is the ambient temperature. And this is this temperature, which is this one, right? Now, this is our initial temperature. Now, what is it that we have to do now? First thing first, we need to be able to find the initial temperature. We need to find the initial temperature first and foremost, right? How are we going to find the initial temperature? We're going to come to the first temperature that we got, which is 40. And then that means time was 0, right? Time was 0. So it's equals to, right? We're starting with it. So we're just going to say 40 is equals to Ti 0 plus 325. Then 40 minus 325 is equals to, then e to the power 0. So it's going to be 40 minus 325, that's minus 285, is equals to Te, right? So this is equivalent to 1. So that means T initial temperature is 285, right? Initial temperature is 285. Our initial temperature is 285. So we have to rearrange the equation. T is equals to negative 285 e to the power kt, then plus Tm, which is 325. Right, so this is our equation. Now, what is it that we have to look for? Let us look for K. Let us look for the constant proportionality, or the rising or the drop, which is now, this one is the rising rate. So we have to look for constant K. Now T is equals to, actually, what is our T? Now, the question said, after 20 minutes in the oven, the temperature of the chicken was 60, right? Now, we have something that we can use to find that K of ours. So we're going to use T20 is equals to 60, right? So now we're going to say 60 is equals to negative 285 e to the power K and 20, then plus 325, right? So we're going to say 60 minus 325 is equals to negative 285 e to the power K 20, right? 60 minus 325 is equals to negative 265 is equals to negative 285, then 20k. Right? Now we have to divide both sides by 285, negative 285, then e to the power 20k is equals to divided by negative 285. So that's 53 divided by 57. Right? So now we have to apply logarithm, natural logarithm. Then from there, 20k ln of e is equals to ln of 53 over 57. Right? Now this one is proven with the rules of log. It's 1. So that means it's 20k is equals to ln of 53 over 57. Right? K is equals to 1 over 20 ln of 53 over 57. Right. Now, how do we go about this? Now we have to write it back to the equation. We have to write it back to the equation, which is t minus t is equals to minus 285 e to the power. Instead of k, we have to write 53 over 57, then plus 325. Right? So this is our equation. This is our equation. Now we have to now answer the question. The question says, how long must the chicken remain in the oven? So that means we have to find our t. So how are we going to find our t? We're now going to say the temperature that is given, it's 185, because they said how long must the chicken remain in the oven to reach a temperature of 185? Now this is our temperature. So how long, right? What time is it going to take to reach 185? Right? Now 185 is equals to negative 285 e 1 over 20 ln of 53 over 57, right? And t, and plus 325. Right? Now 185 minus 325 is equals to negative 285 e to the power 1 over 20 ln of 53 over 57. Right? Now 185 minus 325 is equals to negative 140. Right? It's equals to negative 285 e 1 over 20 ln of 53 over 57. Right? Now negative 140 divided by negative 285 is equals to e 1 over 20 ln of 53 over 57. Right? We still have in that time. We still have in our time. Right? Now negative 140 divided by negative 285, that will give us 28 over 57 is equals to ln of 1 over 20 ln of 53 over 57, then t. Right? So automatically we need to use natural log. There is nothing we can do. This is the only strategy we have to can solve for t. Right? So we are going to say ln of 28 divided by 57 is equals to ln of 120 1 over 20 e to the power 1 over 20 53 over 57 t. Right? Now we know the rule, the exponent is going to come up front, then this one will be left alone. Actually, let me just do it because we might not be understanding this the same way. We have to take this up front, so it's going to be 120 ln of 53 over 57, then ln of e. Right? So what I'm saying is that this one is proven that it's 1, right? And here there is t, right? Because there was t here. I hope you get that. I somehow forget it. So we're going to divide both sides by, right? So we're going to divide here as well by, and then we're going to leave t. So basically our t is equals to ln of 28 divided by 57 over ln of 53 over 57 divided by 20. Right, now we are going to now play with the algebra. 28 over 57. Now we're going to multiply by 20 over ln of 53 over 57. Right, so now what is our t? What is our time? What's our time? Now ln of 28 divided by 57 multiplied by 20 divided by ln of 53 over 57. So what can be the answer? Then the answer is 195 minutes. The answer is 195 minutes. So this is it, right? So this is our answer to the question, right? So please don't forget to